from Zagreb. It is very, very close from here, from Institute of Boskovic. It is a leading and larger Croatian scientific research institute. And there we are some investigation in natural science. It's very close from here. It's just 250 kilometers on south. And I'll talk today about, as you see, some self-assemblies and polymerization in gels. Objective is polymerization reaction in the gels with soft material. We want to keep transcription, gel structure to the polymer, and preserve the structure or morphology of gel network to obtain new materials with improved properties. If you do photochemistry on polymerization solution, usually we will obtain two-cycle addition. But if polymerization occurs in a gel or in self-assembly, should obtain polymers. Actually, here is some 10 micrography and semi-micrography of starting gel materials in a mixture of DMF and water. And another is the same picture of obtained gel. But I'll start from the beginning. I'll talk some about gels. Gels are very important in nature. Usually we say that the cytoplasma made of cytosol protein filament who made gel structure of cytoplasma. Its proteins are very important because all living functions happened in cytoplasma, and also it is important for growing of cells, metabolism, or in replication. And now gels, we should some definition of gels. Gels are viscoelastic materials. They immobilize a large amount of solvent. We should divide the gels to chemical gels, polymer gels, and physical gels. Physical gels are supramolecular, and these chemical gels are just a polymer. They bound to a large amount of water by process of swelling. Supramolecular gels are something different. They are usually made of small compounds, small organic compounds in process of self-assembly. They should make fibers. And these fibers, after that, also like polymer gels, should mobilize solvent. It is a thermodynamic reversible process when you keep it, these gels in room temperature. We should go to the website and obtain a component of gels. How it's work? Gels, here is a picture of gels. It is made of fibers. Fibers connect to the bundles of fibers, and after that, that make three-dimensional network. It's a gel network, and here is a picture, 10 pictures of three-dimensional networks. Okay, before 20 years, we start with a very simple molecule. It's a derivative of this oxalamide gelatos. They usually have some amino acid here. Usually it is phenylalanine leucine or valine here. And synthesis of this complex is very simple. It's just 2 steps. We start with amino acids with chloride, halogen chloride of oxalic acid. We obtain our compounds in yield of 40 to 40%. These compounds should gelate some solvent like water, ethanol, dioxane, stat, something like that. And how self-assembly was made. It was made usually with hydrogen bond between oxalate compounds, oxaloamide compounds in one dimension, and in other dimension also obtain hydrogen bond with acid compounds. And third connection is through the hydrophilic or lipophilic interaction in residues, acid side chain residues. Here is also this interaction we should study with NMR here, and if compounds are higher, we should study with CD. Okay, here's now 10 images of some of these gels. They are made of fibers, and diameter is 10 to 100 nanometers. Length is about 100 micrometers. We will describe this process in this paper from macroscopic level to also, we are working on some derivatives of fumaric acid. Oxalic acid is very similar to fumaric acid. Fumaric acid, like oxalic acid, should make this connection with hydrogen bonds. It is part of our job when we start to switch with photochemistry cis to trans isomer, and they obtain when we change molecules, molecule geometrical molecule, we change also morphology of system. We start with the cis form in water. It is form microspheres, and when we shine that with UV lights, we obtain polymerization and obtain molecule in a geometric. They could form gels and hydrogen bonds. Okay, and also in this study we obtained few crystal structure. From the crystal structure show to us that molecule of fumaric acid, some methyl derivatives are connected with hydrogen bond, and what we know before. And another interaction should be with the lipophilic part of lysine here, leucine here as shown here. Okay, And also we obtain another part, another crystal structure. It is from urine. The molecule connection are very similar. In one dimension, they are connected to the hydrogen bond, and in other dimensions, and they are connected to with hydrophilic interaction. Okay. It should be some kind of chemical reaction with because gel you have two phases. One is liquid phase and another is solid phase. Molecules are crossed in solid phase, and to obtain a polymerization, we must do that in a solid phase. There are some rules. Schmidt rules, they say that distances of functional group must be below 4 angstroms, and orientation is very important to polymerization reactions. Okay, our compounds, some derivatives have distances about 4 angstroms, and we should try polymerization with some of these derivatives. Okay, here is a few examples from literature. First is from Ben Feringa. It is work before 20 years or something like that. She started with trans cyclohexane derivatives, and they have vinyl esters on the end. When these molecules are similarly connecting with hydrogen bond in gels, and when they irritate these gels here with high pressure lamp, they obtain a polymerization. And B pictures is the same lithograph of benzene gels after irradiation. They obtain after transcription of gel network to the bond. Second example is from Weiss. He was working with DNs, molecule like that. They have a long alphabetic chain, and they also do some gels in silicon oil. After UV expose it to light, they obtain a polymer. And here's a picture of this. Okay, and we should actually start with gels. We should polymerize our gelators. These bundles, fibers inside the gel. In other case, we should polymerization of metals and obtain some materials with nice okay, we can obtain a polymer matrix. And from this first compounds, we should we do some modification, and on fumaric acid we put here a vinyl acid, and design molecules what we call bis amino acid fumaramides, and also here is example of mono amino acid fumarides with long chain. Synthesis here is synthesis we obtain in a few steps, reaction steps, final compounds. In a moderate yield, but it is about 50 to 60%. Also, here is a scheme of synthesis of monoamino acid fumarate derivatives. Here's the gelation properties. These mono derivatives should gelate some polar solvent or mixture of solvents and some lipophilic solvents like toluene, silane, or some other organic solvents. This amino acid fumarate should gelate also a mixture of solvents like DMF and water, and they do good gels with acetone or maybe ethyl acetate, and also they gelate toluene. And here's a micrograph picture 10 from compound 1. It is leucine derivatives in DMF water gel networks. Okay, now we start with to conclude just to claim hydrogen bonding of this network. When we do some temperature NMR, chemical shift of these compounds are on down. It is done when gel dissolve and this hydrogen bond break. Similar, we can do this with here in Spectra in a range of 20 to 85 degrees. Here is a region of bonding, NH, and here is his with cooling it disappeared, and pick on obtain stronger peak for non-bonding hydrogen atom. Also, we do some 2D NMR noise spectrum, and we should see some interaction with to the space with the end vinyl groups and center fumarolate groups. It is here, here, and here. It is impossible in a molecule. We do some molecule modelings and obtain geometry of this molecule. Is too far. It is these distances are on 7 angstrom, and it is not visible in noise spectra. So we conclude that this interaction become on the second molecule, and this connection show intermolecular association. We do also some molecule modeling and obtain that our reactive linear groups are in a distance about 3 to 4 angstroms. It's enough to obtain polymerization reaction. Okay, we was do polymerization with gamma radiation initialization, and with UV radiation. Also use mercury lamps, high pressure mercury lamps, and we use photo initialization on benzophenone. in a concentration of 5%. What we obtain, we should follow the reaction with XRD pattern. Here is the starting materials, and here is the spectra after radiation of 40 kilodegrees and 50 kilodegrees. After 50 degrees, it's about 1-2 hours. Our samples should become some disorder in peaks that should become from obtain new structure. Okay. Also, we should follow reaction with ER spectra. Here is the example. Red line is a spectra of starting materials. We should see a group of linear groups, and after polymerization, these peaks are disappeared. It's evidence that we obtain a polymer. And here is also 10 and 7 pictures obtained. In first line, you should see 10 images of fresh prepared gel, and second is obtained after polymerization. If you look in polymers, there are still gel networks, and we should say that we obtain new materials with transcription of gel networks to the polymers. If we do a polymerization reaction in solution after UV radiation, we obtain just amorphous polymers. Okay, here's the properties. These new polymers are insoluble in most organic solvents. It is highly porous materials. Melting point is higher than 300 degrees, and this compounds has possibility of swelling. Various of solvents you should see here. Here's a picture of 10 polymer and polymer after swelling. Here's quantities of solvents what this new polymers carries solvent. In conclusion, I should say that gamma irradiation of these compounds forms insoluble solid materials polymers. Similar isomerization and with UV rays with initiator of 3% of the methylphenol also results with complete polymerization. And we should say that morphology of resulting polymer, it is determination by electron microscopy, is confirmed that polymer form a polymerization that obtain in a supramolecular gel fibers, and that morphology of gel networks was described into the polymer. Acknowledgements, Tomislav Gregoric, he was done for PhD thesis, most of his works, and also Dr. Janja Makarevic, she does the synthesis characterization, and he was worked on gamma radiation. Some results we already published at the beginning of this year in Polymers, and we should try to publish the second publication with the rest of our results. Also, I want to acknowledge to the laboratory for supermolecular chemistry. Here is the members. Let's say Makarevic as a senior sciences student on this project, and also PhD student Tomislav Gregoric. For financial support, I should acknowledge a Croatian Science Foundation. Here's a number of projects. Also, cost action on system chemistry, and Ministry of Science and Education of Republic of Croatia. And thank you for your attention.